So, what do? You guessed it. Type in your matrix. Put it in reduced row echelon form. You put the zeros in or don't put the zeros in, it doesn't make a difference. Ideally, you type it in correctly. We just need the trivial solution to show that they're independent. All right, so x would be the zero vector. Therefore, v1, v2, v3 are linearly independent. And therefore, a basis of R3. And what that means, again, I mentioned things. And I promise that they are formally discussed later on. And usually when they are formally discussed later on, it's after you've had enough time to forget about the original conversation to begin with. So I mentioned basis over and over again throughout the first half of the course with the promise that it would come up over and over again. What this means is that I could write any other vector in 3 space as a linear combination of these 3 vectors, right? Because they row reduce down to our ijk vectors. Now, this would be a linear transformation. This would be some kind of transformation because we'd be living in a world where I is going to 1, 2, 1, j is going to 1, 0, 2, and k is going to 1, 1, 0. So we would be morphing our 3 space to look differently. That's that whole alternate universe reference, but it would work. We could come up with any coordinate in 3 space using these units. All right. In a very simplistic comparison, it's like going from inches to centimeters. Right? You have a way of converting from one to the other. Right? That's really what it comes down to. All right, then we talked about basis decomposition, which is just basically saying that if you know the basis of a particular space, then you can write it in terms of the units that make up that space. So if we're talking about real space with our typical I and j basis vectors, I, j, k, then we could write 3, 4 as 3i plus 4j, but since I defined instead of I 1, 0 as e1, I'll say 3e1 plus 4e2. And then the next one would be, well, I don't even have to look. It's e1, e2, e3. So e1 minus e2 plus 4e3. All right. Okay, so to find the basis, linear combination, construct the augmented matrix, reduce into echelon form, reduce row echelon form. Find the ones that have the pivots. Those make up your basis vectors. Everything else you should be able to write them in terms of, or as a linear combination of those basis vectors. All right. So here's our set S. What I would want to do is write it in reduced row echelon form. So 3 by 5. 1, 0, 2, 0, 1. 0, 1, 3, 0, 3. 0, 0, 0, 1, 2. Quit. Oh, why? 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 Dumas. I don't even look at stuff before I start doing stuff. It's already there. All right, so again, like I said, you should be able to write column 3 and column 5 as a linear combination of columns 1, 2, and 4. All right, so that's something that I could ask you to do on a test. So identify the basis and then write the other columns as linear combinations of the basis vectors.
What was that? E1, E2.
What's that?
E1, E2, A1.
Right. Oh, sorry. They were given names. I should have used the names that they gave, wherever they are. It would be E1, E2, and E. Okay. Well.
Yeah, they did like E for the pivots. So on a test, if you had to write it, it would be like like 2 E1 plus 3 E2 equals, like A1.
Yeah, A1, E1 plus A2, E2 plus A3, E3 equals 230, for example, and then solve that out.